If it's an absolute value, it has two answers. And that's because, as you remember, the absolute value is the distance from 0. So the absolute value, if the absolute value of x is 5, 0, that means x could be 5 or x could be negative 5. It's just a number that is 5 units from 0. Okay? So if this is x plus 1, then x plus 1 is 5 units from 0. Okay? So, and then we're going to talk about how to solve that. So here, x is 5/7 from 0 in either direction. So x is 5/7. Make sure you're writing down the note. Or x equals negative 5/7. So just like with our 5 up there. All right? That's what absolute value is. So an absolute value then, you'd never have a negative over here. If I had a negative here, and we'll get to this later today, there's no solution. There's no x that could make that true. Because once you take the absolute value of something, this side has to be positive. Okay. So we're looking for values of x minus 2 that are 4 units from 0. So x minus 2 is going to be 4 or negative 4. Okay, so x minus 2 equals 4. X minus 4, x minus 2 equals negative 4. Okay, now we can solve. But this, so one way to remember this is the easy one, where I'm just taking the absolute value signs away. So it's just, it looks exactly the same, but without the absolute value signs. And then the other one is going to be exactly the same, but this number will be the opposite of that number. So if that's positive, this will be negative. Okay, so now we're going to add 2 to both sides, x equals 6. Or if we add 2 to both sides, here we get x equals negative 2. Anybody have an answer? What'd you get?
X equals 2 and x equals negative 5/6.
I got negative 6/5.
Yeah.
Did you divide the wrong way?
I just put the wrong thing on the top.
Good. So this is the easy way. That's a common mistake, by the way. This is the easy one, where I'm just taking the absolute value signs away. And then we have 5x minus 2 equals negative 8. We're going to add 2 to both sides. This is an or. Equals 10. So x equals 2. 5x equals negative 6. So one way to, that's a very common mistake, what you just did. One way to not make that mistake, if it helps you, is to do that. So then you have x equals negative 6/5. Here's an even more common mistake. Everybody seems to want to do the distributive property here. You guys like that distributive property so much, you want to do it everywhere you see it. You can't use the distributive property when they're absolute value signs. Sometimes it'll work, and you get the right answer. It doesn't always work. It frequently does not work. Again, you must get the absolute value all by itself, and just one of them on the left side. So it's just like if you were simplifying a two-step equation. So you're going to add the 3 and then divide by the negative 4. So let's do that. So we have negative 4, 3x plus 1 equals negative 8, because negative 11 plus 3 is negative 8. Divide both sides by negative 4. We get 3x plus 1 equals, so it's positive 2. 3x plus 1 equals 2, or 3x plus 1 equals negative 2, because 3x plus 1 is 2 units from 0. So now 3x equals 1, or x equals 1/3. So we're subtracting 1 here. 3x equals negative 3, x equals negative 1, right? Do you have one?
X equals 1 and x equals 1/2.
That's what I got. Okay, so we subtracted 5 from both sides. And then we divided both sides by 2 equals 1. So then we have 4x minus 3 equals 1. or for x minus 3 equals negative 1. So then for x equals 4, x equals 1, or for x equals 2, so x equals 1 half. So I'm going to subtract 5 from both sides. 7x plus 2 equals negative 7. No solution. Because an absolute value doesn't matter what's inside here. When you take the absolute value of it, it has to be positive. So this is impossible. So you'll like that when you get one of these on a test, because you're done. You can write no solution. Don't leave it. This isn't your answer. This is your answer. There's no solution. Okay. So do the U-try. X plus 1 equals, the absolute value of x plus 1 equals negative 2. Impossible. So it's no solution. Absolute value cannot be negative. No solution. Okay. Inequalities involving less than. All right? These are the ones that use and. And remember, we called them conjunctions last week. Okay? Now we're going to do the same inequalities, but with absolute value. Okay? So inequalities of the form x, absolute value of x is less than a. What this means, and actually let me back up. Do you remember in Algebra 1, did your teacher ever give you any ways to remember? Oh, I see. Did you ever see this? Rosanna, did you ever see Go LA?
No.
Okay, so greater than is or, less than is and. This is a less than, so it's an and. If this were a greater than, then we'd get an or statement, and I'll go into what I mean by that. Another way to remember it, it's a very silly little trick, is great or less than. Kind of a dumb little thing, but whatever works to help you remember that when it's less than, it's an and, okay, which is going to give us a conjunction. And when it's greater than, it's an or, which we'll talk about next. Okay, so if you have a team you like at LA, Go LA, might be something you can remember. Okay, so let's think about this. This is x is less than 3. This represents all the numbers whose distance from 0 is less than 3. So its distance from 0 is less than 3. So it's between 3 and 0, but it's also between negative 3 and 0. Classic and graph, okay? With just a segment. And in this case, open circles because it's less than. All right? So you can write this 2 different ways. Like that, or the classic way, which is you take this, and the easy way, just like with the equality, is just to take away the absolute value sign, and since it's a less than, we're going to put and then the second one is going to be x, and we're still switching the sign over here, but we also have to flip this, reverse the inequality sign. So we're switching this to the opposite, and we're reversing the inequality sign. So there's several things to remember here. Whether this gives you an and or an or, and for the second one, you're reversing this and making that the opposite. That's a lot to remember, and you need to do all 3 things. Okay, now, this means the same as this. Generally what I do, if I have a less than, an and statement, I go straight to writing it this way. Just because then if it's x plus 2 or 3x plus 4, then when I go to simplify, it's a little easier. Because whatever I do to the middle, I just do to both sides. The inequality. So right away, I know this is an and, because it's a less than. It happens to be a less than or equal to. So I can write it as x is less than or equal to 2.1, and greater than or equal to negative 2.1. Okay? Same thing as if I had the and. Do you want to see the and statement as well? Okay, so the and statement, this is x is less than or equal to 2.1 and x is greater than or equal to negative 2.1. So I reversed this sign and I switched this to a negative. Now notice that this says the same thing as that. This is x is greater than or equal to negative 2.1. It's the same thing. Okay? It's the same thing. So you can go straight to this if you have an and, if you have a less than. Okay, so why don't you try number 10? Yes.
Negative 3/4 is less than 2x and 3/4 is greater than x.
Perfect. Or, yeah. So you can write, or you could have written x is less than 3/4, which is just the same thing without the absolute values, and, x is greater than negative 3/4. So we've got, in this case, x plus 2 is less than or equal to 3. So we're looking for values of x where x plus 2 is less than or equal to 3 units from 0. Okay? So we have our easy one is x plus 2 is less than or equal to 3. And then we have x plus 2 is greater than or equal to negative 3. But again, an easier way to write this is just as, okay, this is the same thing as that. Negative 5 is less than or equal to x is less than or equal to, we're just subtracting 2 from everything, 1. Anybody have an answer? Yes.
Negative 4 is less than x and 6 is greater than x.
Yeah. There it is. Because this is x minus 1 is less than 5 is greater than negative 5, and then we're just adding 1 to both sides. Okay?